Today is the day that we put all the factoring we've learned together. This is factoring completely. You're going to see here that we can use multiple kinds of factoring in one question. These are the things you need to keep in mind. Always, in every question you do, look for a GCF first. It's the first thing you look for. Take care of it. Then we have standard form. How do we recognize it? It has three terms. First thing we did was the basic kind. That was when the number in front of the square term was 1, a was 1. Then we all need to look at the last number and figure out factors of the last number that added and subtracted to make the middle. But if a was not 1, if a, the number in front, was say 2, 3, 4, 5, those numbers help create the middle term, and we have to come up with a different way to factor it. And what we did was we multiplied the first and last coefficient and found factors of that multiplied to that added to the middle term. The next thing we learned was difference of squares. How do we recognize difference of squares? It's got to have two terms. And the word difference means subtraction. You have to have two terms, subtraction, and they must be squares. For example, a squared minus b squared would factor to a plus b times a minus b. The middle is really 0 because when you FOIL, the inside, in this case positive ab, and the outside, which is negative ab in this case, makes 0. So you end up with 0 in the middle. And I mention this because this is what we do right here in standard form. We factor by grouping. Factoring by grouping is its own kind of factoring where you have four terms and you pair them up, you group them in such a way that the first two have a GCF and the last two have a GCF, and then you do another GCF to factor it into a final answer. That's exactly what you do when you do the hard type of standard form. What I'm going to do is give you an example of each type of question. So if you get stuck, you can fast forward ahead and find a problem near that's like the one you're doing. Number 1, factor 5x squared minus 80. Remember, the first thing you do, the number 1, is look for a GCF. And 5 and 80 are both divisible by 5. So we pull that 5 out using distributive property. 5 times something makes 5x squared. Well, that would be x squared. And 5 times something makes minus 80. That would be minus 16. Then we look at what's left. And notice x squared minus 16 is something you should recognize. It has two terms. It has subtraction. Both are squares. 16 is 4 squared. X squared certainly is square. It's a difference of squares. What we do then is we bring down the 5. Bring it down as part of the answer. You must have it in the answer. And we ignore it, and we look at x squared minus 16 as a difference of squares. We know that x times x makes x squared. We know that this number times this number makes negative 16. So it's a positive times a negative. Remember, really the middle is 0. You need factors of 16 that subtract to 0. It's really x squared plus 0x minus 16. But it's a difference of squares. They've got to be squares for this to work. That's why it's 4 times 4. And as I said, the outer and the inner make the middle term. Positive 4x on the inside, and x times negative 4 on the outside is negative 4x. And when I add positive 4x and negative 4x, I get that middle term of 0. My answer then is all of this, and you need the 5, all of this in the box, if you multiply it, will end up with what you started with. Question 3. You'll notice that 164 are perfect squares, 8 squared and 10 squared. If you did it that way, you'd be wrong. First of all, x is not a square. This isn't a difference of squares as it's written. The first thing you look for is a GCF. 164, they're at least divisible by 4. Let's try 4 and see what happens. They both have an x. I'm going to pull out 4x. 4x times the first spot makes 100x cubed. That would be 25x squared. And 4x times the second spot makes negative 64x. I believe that's negative 16. Now we bring down the 4x as part of the answer. You need it. And this is two terms. It has subtraction. And both 25x squared and 16 are squares. It's a difference of squares. I know that 5x times 5x makes 25x squared. I know that 4 times 4 makes 16. And it's negative 16. It's got to be a positive 4 and a negative 4. And when you FOIL it, the inside becomes positive 20x. The outside becomes negative 20x. And those two together make 0, which is why you don't have a middle term. My answer then is all of this. 4x times 5x plus 4 times 5x minus 4. Question 6. It definitely has a GCF. 3 and 27 are divisible by 3. Both have an x in them. This just has a single x. This has 3 of them, x times x times x. In common, they have a single x. There's 3 b's here and 1 here. In common, they have a single b. Now I'm thinking the distributive property. 3xb times the first spot makes 3xb cubed. Well, there's only one b here, so I need 2 more to make b cubed, minus 3xb times the second spot makes 27x cubed b. I need a 9 to make 27. I need 2 more x's to make 3 right here. Bring this down as part of the answer, 3xb. This is a difference of squares right there. B times b makes b squared. 3x times 3x makes 9x squared. It's negative 9. It's got to be a positive 3 times a negative 3. And all of this is my answer. Question 7. You might be tempted to factor it just as it is, because both of these are perfect squares. You might say, hey, it's 12x plus 10y times 12x minus 10y. Well, the thing is, you haven't really factored it completely if there's still common factors in each parentheses. Do you see how 12 and 10 both have a 2 in them? And that happens here. 12 and 10 both have a 2. That tells you missed a GCF. At the very least, a GCF of 2 times 2, which is 4. In the original question, there is a GCF of 4 in both terms. Remember, the first thing you always look for is a greatest common factor. Always do that first. We need to pull out that 4. 4 times something is 144. I believe that's 36. 36x squared then. And 4 times something is 100. That would be 25. 25y squared. That 4 is part of the answer. Bring it down. And as the previous examples, this is a difference of squares. It's two terms, it's subtraction, and we got squares everywhere. Looks like 6x times 6x makes 36x squared. 5y times 5y makes 25y squared, and it's negative 25, which means it's got to be a positive 5 times a negative 5. And if you FOIL this, the inside becomes positive 30xy, and the outside becomes negative 30xy. And those two together make 0, which is why you don't see a middle term there. This is your answer. Notice how this one's different. It has 3 terms. 1, 2, 3. And the kind of factoring that has 3 terms is a standard form. And you would be able to factor this if you just multiplied 3 and 72 and found numbers that worked. But one of your factors would have a common factor inside it. Because the first thing you should look for is a GCF. And these all have a GCF of 3. Pull that 3 out. It makes the question easier. 3 times z squared is 3z squared. 3 times 11 is 33, so 3 times 11z. And 3 times 24 is 72. We bring this down. It's part of the answer, 3. And this is a standard form. There's no number in front now because that's a 1z squared. All I need are factors of 24 that add to 11. It's a positive 24, so it's either 2 positives or 2 negatives. The middle's a positive, so it's 2 positives. Factors of 24 that add to 11 are 3 and 8. And that's the answer. Question 10. Another GCF. They all have a 4 in them, and they all have a t in them. 4t is my GCF. 4t times t squared is 4t cubed. 4t times 10t is 40t squared. And 4t times 25 is 100t. Bring this down as part of the answer. 4t times 2 sets of parentheses. We know that t times t is t squared. This is the easy kind of standard form again because there's no number in front. I know that this number times this number makes positive 25, so it's either 2 positives or 2 negatives. The middle is a plus, it's 2 positives. Since there's no number in front of the t squared, I need factors of 25 that add to 10. Looks like that's 5 and 5. This could be written another way. It could be simplified a little bit. This is 4t times t plus 5 quantity squared. Now, it should accept either answer, but this is the one that is preferred most of the time because it's a little bit shorter and simpler. But realize that anything times itself, like t plus 5 times t plus 5, is t plus 5 squared. Question 12, another GCF. 5, 45, and 70 are all divisible by 5. Every one of them has a y squared in them. 5y squared times y squared is 5y to the 4th. 5y squared times something is 45y cubed. That would be 9y. And 5y squared times something is 70y squared. That would be 14. Bring this down as part of the answer, 5y squared. There's no number in front. I just need factors of 14 that add to 9. That'd be 2 and 7. Y times y is y squared. This number times this number makes the 14. And it's positive 14, so it's either 2 positives or 2 negatives. And since the middle is positive, it's got to be the 2 positives. And factors of 14 that add to 9 were 2 and 7. Question 15. We have a GCF. They all have a 5 in them. They also have an x in them. Pull that out. 5x times the first spot makes 5x y squared. That'd be y squared. Minus 5x times the second spot makes 55xy. That would be 11y. And 5x times the last spot makes 150x. About plus 30. Bring down the 5x. It's part of the answer. And factor. This times this makes positive 30. So it's either 2 positives or 2 negatives. The middle's a minus. It's got to be the 2 negatives then. Factors of 30 that add to 11. Hey, those are 5 and 6. And there's my answer.